In this video, we will see how we can read from keyboard different data types in C programming language. Let us see few examples, working examples for the purpose. Here, what I have done is I have already made few programs. One of them is this. On the right pane, you will find that I have declared one integer variable. For reading, we use scanf function, a standard library function, which is declared in stdio.h and available in compiled library functions. To read an integer, decimal integer, negative or positive, we need to declare its data type as %d. Okay, and this ampersand symbol before any variable gives the address in memory of the variable. So whatever you type from at the keyboard, it will be read into the memory associated with the variable I. So now next would be printf, which you have already seen in some other video. Value of I equal to %d \n, and then here you are not supposed to provide the ampersand. So here it will read the value from memory being referred to as I, and it will be printed onto the monitor. So let me first execute this program. Read kbd_1. Control C. So what is happening here is it is waiting for me to type an integer. So suppose I have typed 10. Value of I equal to 10, corresponding to this. Next, I have declared a float type of variable, real number. So to read a floating point number, %f is the data type to mention. %f, f stands for floating point number, and again ampersand symbol to indicate the address of this variable. Corresponding to this, printf, I will type something here. It is waiting for me, corresponding to this scanf, it is waiting for me to provide some numerical value, which is real number, 4.3 for example. Value of f equal to 4.3. Now it is again waiting for me to type in some string, char name. This is the way we declare a character array. Suppose the name of the array is name 100, so at the most it can contain 100 characters. But normally the last byte, last location is used to save null character, which is \0, and it acts as something like an end of line kind of thing. Okay, and for reading %s, s stands for string. Here you are not supposed to provide ampersand because the name of an array itself is the address. Take it from me, name of any array is nothing but its address. So here scanf %s, it will wait for me to type in some string or characters. So A, B, C, D, suppose I have typed. It prints A, B, C, D. Okay, so this is a simple program which allows me to print different types of values, integer, float, and character strings. Now let me load another program which I have already written. So here let me change its name. Here it is. Now let me execute it. Here it is. So here I have declared two variables of type integer, I and j. I can read by this, what do I want to say is I can read more than one values of different data type or maybe same data type. Here I have taken example of two integer variables. So I have to provide those many integer variables their addresses. Remember, there should not be any space between these formatting characters. %d space %d, that is not allowed. %d. In scanf, do not provide any escape character, etc. And number of these formatting characters must be same as number of addresses provided here. Okay, so it is waiting for me to type in two integers. So here it is waiting for me. Okay, so now I can provide two values, maybe suppose 4 space 5 I have provided. So it has printed I equal to 4, j equal to 5. So I corresponding to this and j corresponding to this. Okay, now I supplied the values by separating them by space. Let me execute it once again. Now I will supply these two values 4 and press the tab key and then 5. Then also it gives me the same value. Once more, execute it. Now I will supply 4. It has yet not printed anything. It means here it is waiting for me to supply another integer. Okay, which I will do now. It prints both of them. Okay, what does it mean? I can supply the values through keyboard by separating the values by either by space or a tab or new line. All mean the same. These three characters together are referred to as white space character. Perhaps when you use these characters or keys, the effect of pressing these keys is nothing but creating some space which is white in color, white background, and black cursor. So white space, that could be the reason. I don't know exactly. Okay, so now let me have another example loaded 3, and let me execute corresponding program. Now here pay attention. I have written here int I comma j scanf %d. It means I am expecting an integer. Here I will be printing that integer. But next one is another integer, two integers one after the other. So what is the effect? See, it is waiting for me to type in some integer. Now suppose instead of integer, I type some floating point number. What has happened? It has printed 4 corresponding to this I. But corresponding to j, it did not stop. Okay, it did not stop corresponding to this. Actually, what happens is every device in C program has associated buffer and a device file. So in C language, standard input device is stdin, and there is a buffer associated with it. So whatever you type at the keyboard, standard input device is keyboard. Whatever we type at the keyboard, it goes to that buffer, and that buffer is cleared if and only if the expected data type and provided data type are identical. So here it assumes that you have typed I corresponding to first type 4 in response to scanf %d. So it takes 4 and 0.3 remains in the buffer. So it will not wait for you to type in another value. It thinks perhaps that the value is already there which does not match, so it prints j equal to 0. Remember, you may find j equal to 0 here in this case, but you cannot rely on it. And under some implementation I have seen, it prints some arbitrary value. So we cannot trust the value of j in this case. Okay, what we can do is we can again run it. again run and type zero point 0.3 only. This happens to be real number. Now you can see here, value of I is some arbitrary value and value of j is arbitrary value. Okay, because it has not cleared the buffer and it did not find any corresponding integer, integer corresponding to variable I and no integer corresponding to variable j. So it prints arbitrary values. So if expected type of data and provided type of data are not same, results are not guaranteed. Now let me load another program which I have written. Now let me execute it. 4. Now what is there in this program? Two floating point numbers. So here it is expecting one floating point number. Here it is expecting another floating point number. Okay. Now here if I type 3, it prints the value of 3. Though I typed as integer, it takes it as floating point number. Remember, all integers are real numbers also. Floating point numbers also. That is why it has printed 3.000000. Okay. Now next value I can type 5.2. It takes like this. Okay. So remember, all integers are floating point numbers also. So in response to floating point number, if you provide integer, it is not at all an error. So let me load another program. Now let me execute this. 5. Now what is here? Here it is one integer, one floating point number. Okay. So here it will be it is expecting an integer and here it is expecting a floating point number. Okay. So what should I do here? I will type maybe some example 4.5. 4.5. Now you can see here. It has again not waited for me. It was expecting integer. First integer here on the right hand side you can see. So I typed 4.5. So 4 was extracted as an integer assigned to I. But remember, in previous video, I had told you that even writing 0.5, it will be treated as a floating point number. So it satisfies its requirement. F1 is assigned 0.5. So it is not waiting for you to type in another float. So in response to reading int I, you type only one value. It does not stop for the second value to be keyed in. It automatically takes it. Okay. So this is a typical behavior of scanf. Now let me load another program which I have made for you. Okay. Now this is corresponding to this. Let me execute this program as well. Now you can see here I have declared two integers. This is interesting, and I'll be scanning them as integers. And ch2 I have assigned 66. Printf %c ch1 I read as integer but trying to print them as characters. %c is for characters. So these are the decimal numbers, decimal integers 65, 66, 66. 66 is ASCII code of capital B letter. So in response to this scanf, I will supply suppose 65, which is ASCII code of capital A letter. Okay, and here a character name 100, and then scanf, it is waiting for me to type in something. Okay, so let me type here. I will type, maybe suppose I type 65. Okay, it has printed capital A space capital B because there is a space here right inside. You can see 65 is ASCII code of capital A, 66 is ASCII code of capital B. Actually in C language, characters are treated as 1 byte integers. So you can declare them as integer and read, or you could have declared them as character. Now next it is waiting for me to type in some string. So let me type something, maybe A B C D space E F G. Now you can see here it prints only A B C D. Remember, reading of input from the keyboard by default terminates at the white space character. That is, after A B C D it finds a space, it does not read the next character. Okay, so this is the way scanf behaves in typical manner. In future videos also we would encounter some even strange behaviors of scanf function. Okay, that is all in this video. Thanks for watching.